In this lesson, we're going to try and put the last two ideas together. So we're going to look at expanding brackets, so multiplying things together, but then also collecting things that should go together, like terms, we call them. Remind ourselves of how yesterday worked first of all. When I have brackets, that means multiplying. When I multiply, numbers go with numbers, so 4 times negative 7, and negative 7, negative 28, and letters go with letters. In this case, I only have the 1x, so I only end up with the 1x. Okay. In the next one, however, 2 times 9 makes 18. I've got 1x here and 1x here, and when I multiply things that have the same bases, I add their exponents. So 1 plus 1 makes 2. So I've got 2 x's, or x squared we call that. In the third one, number times number makes negative 15. X's go with x's, and I've got 3 of them. Don't forget to add the 1 in your exponent. Y's go with y's. Y times y, I've got 2 of them, and there's my answer. Okay. This is called a monomial. It's made up of one term. It's got parts and pieces, letters and numbers and exponents, but it's all stuck together because there's no plus or minus signs. When we do problems, regardless what kind of math we're doing, we always apply the idea of BEDMAS. And that is, you do your multiplying and dividing, brackets if you have them, exponents if you have them. We won't really see those today. But dividing and multiplying before you do your adding and subtracting. What that means in our case is we have to get rid of that multiplying stuff first, and then examine our problems to see if there's any adding or subtracting we can do. Okay. Sometimes that doesn't work so effectively. Let's take a look at this question. Can you apply BEDMAS to this numerical expression? Sure we can. Okay, BEDMAS says do brackets first. 2 plus 7 makes 9, and then multiply. 27. But there's actually another way we could have done this problem. Let's take that problem, the exact same one, and look at it this way. What if I were to do my multiplying first? So multiply 3 times 2, but also 3 times 7. Well, 6 plus 21 also makes 27. Kind of a cool idea. I can do BEDMAS inside the brackets and then multiply, or actually multiply and then add. It turns out these come out to the same answer. And there's lots of situations where this comes in really handy, in particular where I can't do the bracket first. And we call this the distributive property. If you can't add things inside your bracket, get rid of the brackets by multiplying first. Then do your adding and subtracting. And we call this expanding. That's our big idea for today. We want to expand brackets, get rid of them, multiply them. For instance, in this question, I can't add x and 6. They can't be added. They're not like terms. So I couldn't actually do the problem of BEDMAS. But if I use my idea of multiplying, multiply, 3 times x makes 3x. Number times number, well, the only number I have is 3. Letter times letter, the only letter I have is x. So let's stick them together, 3 times x. But I also have to multiply 3 times 6, and I get 18. That's it. I've expanded my brackets. Can I go further? Well, if I examine these things, this has an x, this does not. So no, that's as far as I can go. I don't have any like terms. Let's take a look at the next one. Can I add inside the bracket? No. Can I multiply into the bracket? Yes. Negative 4 times 4 is negative 16. There's 1y, so I've got 1y. Negative 4 times positive 1 makes negative 4. There's no y's, so I've got no letters. Can they be added together? No. This has a y, this does not. So I'm done. Okay. Sometimes, we look at C here, we get things that are in weird orders. Remember earlier we talked about you can multiply in whatever order you want. 2 times 3 is exactly the same as 3 times 2. So if things aren't in the right order for you, but you know you're multiplying, I know that because I have brackets and brackets, change the order around. maybe it makes more sense to do this, because that looks familiar. Negative 2 times 3 gives me negative 6, and there's 1x. Negative 2 times negative 2 gives me positive 4, and there's 1y, and I'm done. They can't go together because one has x and one has y, and those are not like terms. Let's take a look at D. Can I add inside the brackets? No. So I have to get rid of the brackets. 3 times 2 makes 6. I've got 3 w's and another w, and when I multiply letters that are the same, I add their exponents. So now I have 4 w's. 3 times 4 makes 12. I started with 3 w's right here. I didn't add any more w's in, so I've still got the 3 I started with. There's my expression. Can I add them together? Well, I've got w's and w's, but this one's a 4 and this one's a 3, and those are not the same. Let's take a look at the last two here. Negative. Ooh, negative what? We're missing a number. What number do we know always goes there? Negative 1. So let's try this. Negative 1 times 8 is negative 8. I see just the 1k, so I've got just the 1k. Negative 1 times positive 7, that makes negative 7. There's no k's involved, so I got no k's in my answer. My answer has k's here, but none here, so I can't go any further. All done. And we'll try the last one here. Can I add inside the bracket? No, I got m's with a squared, just m's, and no m's. Those are all different kinds of things. So I'm going to have to expand. 3 times 2, and remember we're multiplying every time here. 3 times 2 is 6, m squared. 3 times 6 is 18, and the letter m. And 3 times negative 4 is negative 12. Yeah, I still can't collect my things because they're still all different kinds of things. I've got squareds, I got just m's, I got nothings, just numbers. Okay. Okay, we're going to make it slightly more complicated because sometimes I can put things in between or have more than one brackets. Okay, but the ideas stay the same. Get rid of your brackets, multiply, okay, and then collect any like terms that can go together. So this is where the combining the last 2 days comes into play. So let's give this a try. 5 times 3 makes 15 and it has a y attached. 5 times 7 makes 35. I'm done my multiplying because that's the end of my bracket. When I end the bracket, I kind of end that half of the question. Let's start the next half of the question. Positive 4 times 6y. That's 24y. Positive 4 times negative 1. That's negative 4. My brackets are gone. That's just stuff I can do still. Y. Well, I've got 15 y's here. And positive 24 y's here. Those are things that can go together. They're like terms. And if I add them, I end up with 39 y's. Similarly, I've got a positive 35 and a negative 4. Those are numbers, just regular old numbers. They can go together. What's 35 minus 4? Well, that's 31. And it's a positive 31, so I got the plus sign there. That's it. I'm done this question because this has y's and this has no y's, so those ones cannot go together. I'll take a look at B. I got brackets. What's in front of the bracket? It's a missing number. Let's put it in there. A 1. 1 times b. Well, that's 1b. 1 times 5. That's 5. 1 times negative 2b squared. That's just negative 2b squared. Multiplying by the number 1, kind of a nice one. I'm going to try the next half because I ended my bracket. I ended that half of the question. Ooh, this is a negative 2 times 1. That's negative 2. A negative 2 times a negative 2. That's a positive. 2 times 2 is 4, and it has a b attached to it. And then negative times a negative, oh, there's a 1 missing there. Negative times a negative is a positive. 2 times 1 is 2. And I got some b squareds. Okay, I got rid of all the brackets. Let's find the things that can go together. B's, go with B's. Oh, here's some more B's. 1b and 4b makes 5b's. Positive 5. Do I have any things that are just numbers? Yeah, I got a minus 2. 5 minus 2 is positive 3. And I got negative 2b squareds and positive 2b squareds. What's negative 2 plus 2? That's 0. So 0b squareds. In other words, I have no b squareds. So I don't need to put anything else in here. If you really wanted to, I suppose you could put in 0b squared, but it doesn't really make sense to do that because there aren't any of them. So usually, I'll just leave that part out. If there's none of them, don't write them in. Okay. I'm going to try the last two here. This is it. Let's see what we can do. We're going to practice this. This is a tricky concept. I really understand that, so we're going to spend some time on it. So, brackets. Let's get rid of those brackets. I can't add anything inside. They don't go together. So let's expand. 2 times 3 makes 6 W's. 2 times negative 5, that's negative 10, end of my bracket. Negative 4 times 6, that's negative 24. Negative 4 times 2, that's negative 8, and there's a W there. Let's start collecting things. 6 W's can go with minus 8 W's. 6 minus 8 is negative 2, and there's a W. In the middle, I got a negative 10 and a negative 24. That's a whole bunch of negatives. So I got a negative answer of 34. That's it, that's all, because my last two things are not like. Okay, let's try D. Oh, can I do anything inside the bracket? Nope. So I have to get rid of the brackets. What's in front of the brackets? Is it the 3x? Actually, no. What's in front of the brackets is a plus 1. The 3x is actually separated from those things. There's nothing going on with the 3x. It's just 3x. It's the 1 that needs to multiply in. So 1 times 4 is 4. 1 times negative 9 is negative 9. Now I can collect. 3x's go with negative 9x's. 3 minus 9, that's negative 6. And we're talking about x's. And the plus 4, well, there's nothing else with it, so just plus 4. There's my answer, all done. Okay. I think, oh, we got one more question. Sorry, got a little word problem here. Find a simplified expression for the perimeter and area of a rectangle given below. Okay, how do I actually use this algebra stuff? I use it to create expressions. That's kind of why I'm doing this. And then part B, determine the perimeter and area of x is 7. So we're going to spend some time on this question because this is a question we're going to see over and over and over again in this course. How do I find the perimeter of something? Perimeter means distance around. Distance around. In other words, if I add up all my sides, I'll know my perimeter. So let's take a look here. What do I have for sides? I've got 2x plus, I've got 3x minus 1. Those are the ones that are labeled, but there's actually more sides. There's one over here, that's also 2x. It's a rectangle, right? They have to be the same on either side. Plus, what am I missing at the top? Another 3x minus 1. There's my expression, but I can make it a little bit easier because the x's can all go together. 2 plus 3 plus 2 plus 3 makes 10 x's. And the numbers can also go together. Minus 1 and minus 1 makes negative 2. There's an expression for perimeter. Add up all your sides. And that's true for every shape. Add them all up. They also ask for the area. How do I find an area of a rectangle? It's going to help us prepare for our unit down the road because we're going to talk about areas. A rectangle specifically is length times width. In other words, your two sides multiplied together. Kind of what we've been doing today, right? What are our two sides? These are our two sides. So I'm going to multiply 2x times, put a bracket in there, 3x minus 1. Well, that should kind of look familiar. I want to get rid of my brackets. 2 times 3 makes 6. I've got 1x and another x, so I've got 2 x's. And 2x times negative 1. 2 times 1 is negative 2. I've got the single x, so that's it. There's my expression. Can't go any further because I've got squareds here, but only x's here. The last part of this, what happens? Oh, determine the perimeter and area of x is 7. Okay, how am I going to do that? Well, the easiest way to do that is to use the expressions we created. We said perimeter was 10x minus 2. 10 times x minus 2. We just said x is 7. So, wherever the x is, I'm going to replace it with a 7. When things are stuck together, we said that's multiplying. So we can calculate now. What's 10 times 7? That's 70 minus 2 gives us 68, and we're talking about centimeters. And you can do the exact same thing with area. Just use the right expression. Area is 6x squared minus 2x from right there. But what do we know about x? We said it's worth 7. So every time I see an x, I'm going to put a 7 in there. Oh, there's another x, another 7. And what operation am I using? BEDMAS. BEDMAS says exponents. Ooh, 6 stays the same. 7 squared is 49. Everything else stays the same. What's next in BEDMAS? Exponents, division, multiplication. All right, 6 times 49. That's a big one. That's 294. 2 times 7. That's 14. Subtract them, we get 280, and our units are centimeters squared. Okay, that's a tricky question. We're going to see that one a few times. We're going to do it over and over again to get good at that. Maybe change the shape. Maybe it's a triangle or rectangle or square, things like that. But the same idea, so we can see how we actually use this algebra stuff. All right, that was a little bit of a longer one today. Try it. If you're stuck on things, come see me. There's a sheet on the website, of course. Okay, we're halfway through the algebra stuff now. Time.